Hello, hi everyone, good afternoon and welcome to board Brahmastra. My name is Akash and today we are going to learn about prism, the refraction and dispersion through the prism. That is our today's topic. Hello Aditya, hi, good afternoon. So if you are new to this channel, so I'll tell you about myself. I have done PhD in physics from National University of Singapore. I have BSMS dual degree from IISc Pune and I was ranker in IIT Advanced. Alright, तो चलो start करते हैं. तो हर एक मैं अभी क्या करने वाला हूँ, हर एक सेशन से पहले I'll give you one question. So there is a competency based question or there is a question. This if something like this come in your exam, तो इसका 5 नंबर का क्वेश्चन है. So this is like these are quite difficult questions. ओके तो हम लोग बहुत बार देखते हैं ना, अभी नया नया वर्ड आ रहा है कॉम्पिटेंसी बेस्ड. तो कॉम्पिटेंसी बेस्ड होता क्या है एग्जैक्टली किसी को पता है? कॉम्पिटेंसी बेस्ड क्वेश्चंस होते क्या है? तो दो चीजें हैं. एक तो बहुत बार इससे पहले होता था कि बच्चों को रटना पड़ता था कि बहुत कुछ है मेमोराइज करने के लिए, और बहुत बच्चे ऐसे होते हैं सर मुझे मेमोराइज नहीं करना है, ये इतना सब कुछ रिमेंबर नहीं करना चाहता हूं मैं. तो गवर्नमेंट में क्या सोचा कि बच्चों का स्ट्रेस रिड्यूस करते हैं, तो कुछ इंफॉर्मेशन वो खुद से प्रोवाइड करेंगे आपके एग्जाम में, वो खुद से आएगा. मतलब काइंड ऑफ ऐसे ये जो पैराग्राफ दिख रहा है ना, इट इज द इंफॉर्मेशन प्रोवाइडेड एंड देयर इज अ ग्राफ आल्सो. विल डिस्कस दिस एंड उसके बेस्ड पे देयर विल बी सम क्वेश्चंस, 1 2 3 4 डिपेंडिंग ऑन द डिफिकल्टी लेवल ऑफ द क्वेश्चन. तो कॉम्पिटेंसी बेस्ड ये जो है ना न्यू टाइप ऑफ एग्जाम्स, न्यू टाइप ऑफ क्वेश्चन, इससे तुम्हारी लाइफ इजी हो गई है. सो डोंट गेट स्केर्ड, डरना नहीं है आपको, है ना. कॉम्पिटेंसी बेस्ड कुछ नहीं है, जस्ट एक पैराग्राफ होगा, वो पैराग्राफ में सारी इंफॉर्मेशन होगी. मतलब जैसे कॉम्प्रिहेंशन होता है ना इंग्लिश में, सेम वैसा. तो चलो ये क्वेश्चन एंड आई कैन गारंटी यू कैन solve this question by yourself at the end of the session. So just be there, focus and try to understand all the concepts. So let's begin. Refraction through the prism. There is an incident ray or incident light falling on one of the sides. There is a triangular shaped, you see triangular shaped prism. Okay, so now there is a ray, incident ray, there is a direction of the incident ray. When the ray goes, there is air, so from air it is going to the glass, correct? So there is a point of refraction, ray is going from air to glass, so it will bend. So there is a bending. Where is it bending? Towards the normal or away from the normal? You see there is a, okay, this red one is the normal. So this refracted ray, there is an incident ray and there is a refracted ray. So this refracted ray is bent towards normal. Why? Because a ray is going from air to glass. Glass is a optically denser medium. And at the second point, यहाँ पे क्या हो रहा है बताओ? Is the ray bending towards normal or away from the normal? At the second place, it is going from glass to air. Glass is optically denser. Air is optically rarer. So at the second place, it is bending away from the normal. In the first refraction, bending towards the normal, this towards the normal, this red ones, these are the normals at the two interface. Okay, so this angle between incident ray and the normal is called as angle of incidence. The angle between normal and the refracted ray is called as angle of refraction, and this one here is called as angle of emergence. This last ray is called as emergent ray. The angle between emergent ray and the normal is called as angle of emergence. And you see there is a path of the incident ray. If let's suppose there is no prism, तो जो incident ray, this would have traveled in this direction, correct? So the angle between incident ray and the emergent ray is called as angle of deviation. So there is a symbol, this is called as delta. You can either use this symbol or if you don't want, just use D for the angle of deviation. It is the angle between incident ray and the emergent ray. Okay, nice. So now this question also can be asked for 2 marks, something like this. Draw the ray diagrams for the ray passing through the prism. So आपको ये सब दिखाना पड़ेगा, सारे angles आपको दिखाने पड़ेंगे. तो PF, PE, this is the incident ray from point P to point E. Then from E to F, it is the refracted ray. From F to S, it is emergent ray. And now this is angle of incidence, angle of refraction, angle of emergence. A is the angle of the prism and D is angle of deviation. तो आपको ये सारी चीजें दिखानी पड़ेगी. This N, N prime or M, M prime, these two are normals. Normal meaning they make an angle here 90 degree with respect to the interface. जो interface है ना, air glass interface or glass air interface, so these normals make an angle of 90 degree. Okay. All right. So let's do some derivation. This is very important. So lot of people get confused about this derivation. So let's do it. Very simple, very easy in step-by-step format. So you see this normal, there's, let's suppose, N prime, N, and there's, let's say, M prime. Okay. So you see this, these two lines, there's an incident ray, line OP, and at this point P, there is another line which is N prime, N. Can you see? So now these two angles, they are called as vertically opposite angles. What is this angle? This angle is I1. And what is this angle? It is delta 1 plus R1. This is I1. So these two angles, they should be equal. So I can write I1 is equal to delta 1 plus R1. Correct? Or I can write delta 1 is equal to I1 minus R1. Can I write this? Yes, we can write this. So delta 1 is I1 minus R1. In a similar format, you see these two lines. So these two angles, they are vertically opposite angles. So I2 is equal to delta 2 plus R2. So I2 is equal to delta 2 plus R2. And from here, I can get delta 2 is equal to I2 minus R2. Correct? Now, look at this triangle M, P and Q. This triangle MPQ. So there is this angle delta. What is this angle? It is the exterior angle. For example, if there is a triangle, there is exterior angle delta and the two interior angles are delta 1 plus delta 2. So do you know the property of the exterior angle? So the exterior angle is equal to sum of the other two interior angles. So that is delta, which is the total angle of deviation, is equal to delta 1 plus delta 2. Correct? And we know the value of delta 1 and delta 2. So substitute these values in this equation. तो आपको क्या मिलेगा? आपको ये equation मिलेगा. What is this I1 and I2? These are the angle of incidence and angle of emergence. Correct? So instead of I2, I can write it as E, which is our angle of emergence. And from here, जो minus sign है वो मैंने बाहर ले लिया. So in the bracket it is R1 plus R2. Okay? So this is the one equation. Just keep in mind about this equation. We'll use this. Okay? So now in this quadrilateral APNQ, you see this quadrilateral APNQ? तो यहाँ पे this angle is 90 and this angle is 90 because these are the two normals, and because of that ये जो angle है ना पूरा angle, this angle is also 90, this angle is also 90. Correct? So the two angles of this quadrilateral, they are 90 degree each. So other two remaining angles, that is angle A, this is our angle A, plus angle PNQ, this angle A plus angle PNQ. उनका सम क्या होना चाहिए? It should be 180, right? Because the two other angles, they are 90 each. Total of the four angles should be 360, correct? तो और एक ट्राइंगल हम लेते हैं PNQ. ये ट्राइंगल दिख रहा है आपको? So in this, sum of all the angles, what are all the angles? There is R1 here, R2 here, and angle PNQ. So their sum should be equal to 180, sum of all the three angles of the triangle. So now if you subtract let's suppose there is equation 1 and there is equation 2. If you subtract equation 2 from equation 1, this angle P and Q will get cancelled out. This 180 degrees will get cancelled out. So what is left? What is left is this A minus R1 minus R2 should be equal to 0. Correct? Take this R1, R2 to other side. So what you will get? You will get A is equal to R1 plus R2. Yes? Now remember this equation. This is very important equation. And we know the earlier equation. You remember this equation? Delta is I plus E minus R1 plus R2. But just now we have discovered what is this R1 plus R2? R1 plus R2 is nothing but A. So delta is equal to I plus E minus A. Correct? So this is the another equation. So the first equation is A is equal to R1 plus R2, and the second equation is I plus E is equal to A plus delta. Delta क्या है हमारा? Angle of deviation. A is angle of the prism. So these two equations, just remember them. Okay? All right. अभी तक समझ में आ गया सबको? It is confusing? What is confusing? You want to do it again from the beginning? Let's do it again. Then, yeah, I know these equations you don't like. तो वापस से करते हैं पूरा, है ना? From the beginning. So again, remember, what are these two lines? They are crossing lines. So these are the opposite angles. Vertically opposite angles. सुना होगा ना मैथ्स पढ़ते हो आप लोग? तो मैथ्स में आपने ये पढ़ा होगा. So these vertically opposite angles, they should be equal. Delta 1 plus R1. Correct? And from here, I can write delta 1 is equal to I1 minus R1. Correct? And these are also again vertically opposite angles. There is I2, there is delta 2 plus R2. So we can write delta 2 plus R2 should be equal to I2. Correct? And from here, I can write delta 2 is equal to I2 minus R2. Yes? So these are the two equations I have written there. तो इसके बाद अभी ये जो triangle है PMPQ. You see this triangle? I'll use different color. See this triangle MPQ. दिख रहा है आपको ये triangle? So this delta is the exterior angle. So it is something like this. There is a triangle. This point M, P and Q. What is this angle? There is the exterior angle delta. These two are the interior angles delta 1 and delta 2. So do you know property of the triangle? So there is a one property of the triangle that the exterior angle जो होता है, it is equal to sum of the two interior angles. So we can write the total angle of deviation delta, ये क्या है? Delta 1 plus delta 2. Correct? So now total angle is delta 1 plus delta 2. So you just substitute these here. ये दोनों आप इस इक्वेशन में सब्स्टिट्यूट कर दो तो आपको क्या मिलेगा? So आपको मिलेगा I1 plus I2. Correct? Just add these two equations. Minus this minus R1 minus R2. Minus R1 minus R2. So you can simplify this as delta is equal to, okay, there is another equation. Delta is equal to I plus E minus R1 plus R2. So just keep in mind about this equation, we are going to use it. Delta is equal to I plus E minus R1 plus R2. ये भी वापस से करते हैं पूरा. I'll write that equation here. Delta is equal to I plus E minus R1 plus R2. This equation we have derived in the last page. Okay, now you got it? Nice. So now in this figure you see this quadrilateral APNQ. These are the normals, right? These dotted lines, these are normals. So what is this total angle here? This total angle should be 90. This total angle should be 90. Correct? This is 90 because this is normal, 90 degree. So the other angle, this should be 90. The sum of the linear angles is 180. Correct? So now there are four angles. This angle A, there is the angle A plus angle APN. What is angle APN? Okay, I'll just write down angle APN plus angle AQN. Angle AQN. दिख रहा है आपको? Then plus angle PNQ. Plus angle PNQ. These are the four angles of this quadrilateral APNQ. And what should be the sum of four angles of the quadrilateral? It should be 360 degree. Correct? But these two angles APN, this is how much? 90 degree. And what is AQN? AQN is also 90 degree. Correct? So angle A plus angle PNQ, which is 360. So now what is 90 plus 90? 90 plus 90 is 180. You take this 180 to other side, subtract from 360. So what do we get? Angle A plus angle PNQ should be equal to 180 degree. समझ में आ रहा है अभी? Easy? So that's what I have written here. From quadrilateral APNQ, angle A plus angle PNQ is 180. ठीक है? और ये जो ट्राइंगल है PNQ, ये कहाँ पे? This is PNQ. दिख रहा है आपको ये ट्राइंगल? In this triangle PNQ, what are the three angles? This is R1, R2 and angle PNQ. So R1 plus R2 plus angle PNQ, their addition should be 180. So now consider this as equation 1 and this as equation 2. Subtract equation 2 from equation 1. So these two will get cancelled out. These two, they will get cancelled out. So what is left? We got another equation, that is angle A is equal to R1 plus R2. Correct? And now ये हमारा equation था ना? In the last slide we derived this equation. Delta, which is the total angle of deviation, is I plus E minus R1 plus R2. But what is R1 plus R2? Is A. So delta is equal to I plus E minus A. So there is another equation. I plus E, this I plus E, take this A to other side, it is equal to A plus delta. And these two equations are very important. So you will be asked to derive either this equation or this equation, or they can ask you questions based on one of these equations. So you need to know one of these derivation. Okay? Why the direction of current? Yeah, we'll discuss that Aryan when we start learning about electricity. Okay? So now let's solve few MCQs. First question is angle of deviation is. So what is angle of deviation? कौन बता सकता है? It is the angle between incident ray and the refracted ray. Is this correct? Or angle between incident ray and the normal, or angle between incident ray and emergent ray. So which one is the angle of deviation? Angle of deviation is angle between incident ray and the emergent ray. Correct? This is how angle of deviation is defined as. So now, how many refractions occur when the light passes through the prism? So you know the prism, correct? So when the light falls onto the prism, so there is a point where light goes from air to glass. So there is one point where a refraction occurs. What is the refraction? Refraction is nothing but bending of light. So there is an incident ray and the refracted ray. So there is one point where refraction occurs. There is another point where refraction occurs. So how many times light is getting refracted? It is 2 times. Either light will go inside the prism or come out of prism. So only 2, right? It cannot be third. It can reflect here, but again it has to come out. अगर एक बार अंदर गई है इसके प्रिज्म के लाइट तो प्रिज्म के बाहर भी आएगी. So there will be only 2 times it is getting refracted. What is refractive index? Tanmay, we have done that. Refractive index, you can watch the light chapter, the second topic. I have discussed the refractive index. For glass, refractive index, if you want the value, it is approximately 1.5. For air, refractive index is approximately 1. It is 1.0003, but approximately we can say it is 1. Okay? So now, next question. For equilateral prism, what is the angle of the prism? So equilateral prism is something like all the sides are equal and all the angles are also equal. All the sides equal, all the angles equal. So what is the angle of the prism? This angle A, what is this? If all the angles are equal for the equilateral triangle, what will be the angle? Very simple, right? It should be option number A, 60 degree, correct. Nice. Now, the angle of deviation D is given by. So I want to know how many of you remember that derivation, which we done 5 minutes back. D is equal to which of the following? C is right. Okay. You remember I plus E is A plus D. So what is the value of D? So D is equal to I plus E minus A. This is the correct form. Okay? Alright. So now let's learn about dispersion. So what is dispersion of light? Through the prism. So when the white light enters the prism, you see there is a white light. This white light split into 7 different colors inside the prism, and when it comes out, if you place a screen here, you can clearly see 7 different colors. Do you know who was the first scientist to discover this? किसने ये discover किया था कि when the light goes through the prism तो 7 कलर में वो split हो जाती है? It was Newton. Newton discovered this dispersion of light, and he has separated all the 7 colors, and later he has showed that these are the 7 colors exactly as you see in the rainbow. Correct. Nice, Aditya. Total creation. Correct. So now let's learn about the dispersion. तो आपको पता है कि dispersion क्यों होता है? Why there is a dispersion? Let's suppose the light is coming from the sun. It is not getting dispersed, right? But जब ये prism के through से pass होती है तो disperse क्यों हो जाती है? Why does it split into 7 different colors? Any idea? किसको पता है? So these 7 colors, this is the order: violet, indigo, blue, green, yellow, orange and red. These are the 7 colors, and this 7 colors together is called a spectrum. Spectrum of light. Correct. Nice, total creation. So what happens when the light goes through the prism? Different colors have different wavelength. Do you know wavelength? Wavelength of light? Light is a electromagnetic waves. So because it is a electromagnetic waves, it has different wavelength. So for the red, this is almost near 700. The unit is nanometers. Do you know how much is 1 nanometer? 1 nanometer is equal to 10 raised to minus 9 meters. Correct? So this is approximately, we can say approximately 700 nanometers for the red color. And how for the violet color? Violet is the last color, correct? It is approximately, I can say 400 nanometers. Correct? So when there is a change in the wavelength, the violet color has minimum wavelength, red color has maximum wavelength. But do you know one property of light? That the speed is directly proportional to the wavelength. So when the light passes through the prism, the speed of the light change. That is the reason for the refractive index, correct? That is the reason when the light passes through from one medium to another medium, the speed of the light change. And why does it change? Because the different colors have different wavelength. So which color would be faster? Is it the red or is it the violet? Or is it some other color in between? So which color will travel faster through the prism? What do you think so? Red, orange, yellow, green, blue, indigo or violet. Which one will have the maximum speed? You see here, speed is directly proportional to wavelength. So which color have maximum wavelength? It is the red, approximately 700 nanometers. So red color will be faster. The violet color would be slower or slowest, I can say. Correct? Red light or red colors, they travel faster compared to all the other colors, and violet would be the slowest. So now let's look at this diagram again. So you see there is the incident light, there is the incident light, incident ray. So this is the angle of deviation for the red color, correct? And this is the angle of deviation for the violet color. So which color is getting deviated the maximum? Is it the red color or the violet color? Which color has deviated the maximum? What do you think? Yes, red will be traveling faster, correct? So the color which is the slowest, that is our violet color, will have the maximum deviation. Red color, because it is fast, right? It will easily pass through the prism. So it has the minimum deviation. Violet will have maximum deviation. Correct, nice. So in a medium, so whenever we say medium, it means any medium which is a optically denser medium than the vacuum. Anything other than vacuum, so in that different colors have different speed. Different colors of light will have different speed. Will the colors have same speed in the vacuum? What do you think? If let's suppose this prism is made up of vacuum, will there be any dispersion? If the prism, this is a glass prism, right? Instead of that, let's suppose this is made up of vacuum. Will there be any dispersion? Answer is no, because in vacuum all the colors will have exactly same speed. So there will not be any dispersion. Why there is a dispersion here? Because the glass will have the refractive index which is greater than 1. So any medium with refractive index greater than 1, through that medium the different colors of light will have different speed. And because of that, what will happen? Because of this change in velocity with color, this is the reason why we see the dispersion of light. Clear now? Great. So let's solve few questions. If you have any question, any doubt, you can ask in the chat. So the statement is speed of light is same for all the colors or all the wavelengths of light in vacuum. This is vacuum. Will it be true or false? Speed of light is same for all the colors in vacuum. This is true. If the medium is vacuum, just now I told you, if the medium is vacuum, all the colors will have exactly same speed. So that is the reason when the light comes from the sun to earth, it is the white light. There is no dispersion. Light does not separate when it comes from the sun to earth. Only after it enters the earth, then we see the dispersion. Next one, which ray is the least deviated by the prism? Now, is it the violet, green, red or yellow? Which one is the least? Least is minimum deviation. You see this? There is an incident ray. Which ray is deviated the least? It is the red color. Red light is deviated the least. All the other colors, they get deviated more than red. The violet would be, the deviation for the violet is highest. Next question. So now there is a medium. It has refractive index of 1.5. So now for this medium, which color of light will have maximum speed? For example, there is a material of the prism, refractive index 1.5. If the light passes through this prism, which color will have maximum speed? Yes, it is always the red color. Red will have maximum speed. How do you remember this? You know, the speed is directly proportional to the wavelength. Correct? And do you remember wavelength of red color is approximately equal to 700 nanometers. Wavelength of violet color is approximately 400 nanometers. So speed of that color is proportional to the wavelength. When you increase, there is a direct proportionality. So if you increase the wavelength, speed will increase. That is the meaning of direct proportionality. Correct? So the red color will be faster and the violet would be the slowest through this medium. Next one. So which statement is not correct? There are 4 statements here and one of them is not correct. You have to choose the one which is not correct. So the first statement, white light consists of 7 colors. Is this true or false? This is correct. This is true. This is true. Second statement, violet color suffers the maximum deviation. Violet color suffers maximum deviation. This is also true. Red light suffers minimum deviation. This one is also true. And the last one, refractive index of vacuum is different for different colors of light. This statement is wrong. It is false. Why it is false? What is the refractive index of vacuum? It doesn't matter what is the color. How the refractive index is defined as? Refractive index is defined as C by V. But whenever the medium is vacuum, the velocity of light for all the colors is equal to C. C is the speed of light in vacuum. So this will be C divided by C, which is just 1. So for the vacuum, for all the colors, refractive index is going to be equal to 1. So it is not different. Clear? Until now? Any questions, anyone? Great. Last question from this, then we'll go ahead. The cause for the dispersion of light. Why there is a dispersion? What is the reason behind it? Hi Bijoy, shout out to BD Computer Technology. Alright, BD Computer Technology. Total Creation, Villain. Hi Villain, John, Paul, Parul, okay, Harsha, Bimla, nice. Okay, so all the colors of light travel with the same speed, travel with the speed more than that of speed of light. Is it possible? This is not possible. No object will travel greater than speed of light. So this is not possible. Or second option, all the colors have different angles of deviation. Is this correct? Yes, this is correct. But Okay, this statement is correct, but is it the reason for the dispersion of light? Yes, there is a reason. All the colors have different angles, and why they have different angles? Because of the different speed. So now let's understand the other two options. All the colors travel with the same speed. This is not correct. Inside the prism, the speed will be different. And how about the last one? All the colors have same wavelength. This is also not correct. So only correct option is B. All the colors have different angles of prism. And why is that? Because the speed inside the prism is different. Correct? Great. So now there is a concept of recombination. Do you know what is recombination? So when you pass a white light inside the prism, this white light splits into 7 different colors. So there is a red and there are other colors in between. I have not shown, I have just shown the 2 end colors. So now these are coming out of the prism. But if you place another prism which is inverted, then these 7 colors, they will recombine. They will recombine and will form the white light. This process is called as recombination. So what is this process? When the white light falls onto the prism, it splits into 7 different colors, and these 7 different colors, they combine or they recombine to form the white light again. This process is called as recombination. Okay? So now, recombination of the spectrum to produce the white light. You want to talk to me personally? Sure, Bijoy, you can comment in the chat. If I get time, I will talk to you personally. Alright, solve this question. Seven colors of light of the spectrum can be recombined when? So now first option, horizontal position of the prisms. So if the 2 prisms are kept horizontal, something like this, will it recombine the spectrum? No, they will not recombine the spectrum. How about the option number C, adjacent position with respect to each other? They is same as the option number A, right? They won't recombine the spectrum. So this is also not correct. How about option number C, inverted position? That means if one prism is like this, another prism is inverted. Can it recombine? Yes, it will recombine. How about the last one, vertical position? So for example, one prism is like this, another prism like this. They will not recombine the light. So only correct option is option number C. Next one is a critical angle and total internal reflection. So do you guys know what is critical angle and what is total internal reflection? Have you learned this? This is very easy. Let's understand it. So for example, there is a optically denser medium and there is optically rarer medium. Correct? So let's suppose there is a light source here. There is a source and from it light falls onto this boundary. So now there is an incident ray. It is along the normal. So the angle of incidence is 0 degree. So if the angle of incidence is 0, light will just pass without any deviation. So angle of refraction is also 0 degree. Correct? But now you can increase the angle. So there is another ray. Correct? You can draw a normal. This dotted line is the normal. This will be the angle of incidence. So when the light goes from denser medium to the rarer medium, will it bend towards normal or away from normal? What do you think? Light is going from denser to rarer. So when the light goes from denser to rarer, it will bend away from normal. Correct? So this is our angle of refraction. And do you know equation for this? There is an equation which is, if let's say this is the rarer medium, which is let's say vacuum. So refractive index is 1 and this is a denser medium. It has a refractive index, let's say n. So we can use at this interface the Snell's law, and it says that n is equal to sine R divided by sine I. Correct? Now you can keep on increasing the angle of incidence. So for example, if there is a interface, if there is an angle of incidence here such that the angle of refraction, so there is a refracted ray, angle of refraction is 90 degree. For such case, this angle is called as critical angle. Correct? So you can substitute these values. R is 90, so this is sine 90 divided by sine critical. And what is sine 90? Sine 90 is 1. So it is 1 divided by sine of the critical angle. Correct? So there is one particular angle at which angle of refraction is going to be 90. But now, for example, if you increase the angle of incidence, so for example, this I is greater than critical angle. So at this position, what will happen? There will be total internal reflection. There is no refraction. So all light will be reflected inside, inwards. Light will not go to the rarer medium. Correct? So there is shown here, there is a critical angle for this given pair of medium, and if you increase the angle of incidence, there will be total internal reflection. Light will not cross this interface. And this exactly same phenomena is used to explain rainbow. Do you know how the rainbow forms? So there are different, whatever we have learned today, we have to use all of these to understand how the rainbows are formed. So let's understand that. So there is a raindrop. So when do you see rainbow? It is just after the rain, right? There are raindrops which are like hanging in the air. So now there is a sunlight coming from the sun, fall onto this rainbow. It gets split into 7 different colors. This process is called as dispersion. There is a refraction first. Light is going from air to water. So there is a refraction. Also there is a dispersion of light. And at the other end, light does not come out. It gets reflected internally. So all the light is reflected backwards. This process is called as total internal reflection. Total internal reflection. Just now we have studied. Correct? And again there is a refraction from water to air. So these are all the 7 different colors from red to violet, and that's what we see in the rainbow. Correct? All the 7 colors. So what are the different processes that happen? First there is a refraction, then there is a dispersion, then there is total internal reflection. All 3 processes combined to form the rainbow. So isn't it beautiful, these rainbow pictures? Okay, I'll show you. So these water droplets, they act like a tiny prisms which are just hanging in the air. Correct? So what are the different phenomena? They are responsible for the formation of rainbow. So there is total internal reflection, there is a refraction, dispersion. So it is all of the above. So all these phenomena are responsible in formation of rainbow. Clear? And now we are going to solve the competency based question which I had shown you in the first slide. So read the paragraph, after that I'll explain you. So what is this? There is an experiment people have done. So what they have done is, there is an angle of deviation delta. So there is a delta and there is an angle of incidence. Correct? So there is a graph of angle of deviation versus angle of incidence. So in the beginning what happens? When you increase the angle of incidence, the angle of deviation keeps on reducing. It is decreasing, right? But there is a point here. It is called as delta minimum, minimum angle of deviation. So at this point, what happens? People have found that angle of incidence is equal to angle of emergence at this particular point. Correct? I is equal to E only for this particular point. So this is the information provided. There is a paragraph, and based on this paragraph, there is a question that you have to solve. And if something similar comes, this would be like 4 mark, 5 mark type questions. These are called as competency based questions. So how do we solve this? So this is a prism. You remember the prism, and these were the two equations. A is equal to R1 plus R2 and I plus E is equal to A plus delta. So now let's look at this point P. At this point P, do you know Snell's law? Okay, I'll write down the Snell's law. If there is refractive index N1, there is refractive index N2. If the light is passing from N1, there is an incident ray, and let's suppose it will bend. This is a refracted ray. There is, let's suppose, theta 1 and this theta 2. Or instead of that, we can write angle 1. Let's suppose there is angle of incidence here, angle of refraction. So now how do we write Snell's law? It is N1, which is the refractive index of medium 1, into sine of angle in the medium 1, which is sine I, is equal to N2. These are the absolute refractive index into sine of angle R, angle in the second medium. So from this you can write N2 divided by N1, which is sine I by sine R. And what is N2 by N1? It is N21, which is the relative refractive index of medium 2 with respect to medium 1. So that was the question. We have to find out. So okay, I'll read this question. Angle of the prism is 60. So angle A is 60 degree, and angle of minimum deviation, so delta minimum, is given as 30 degree. Correct? So what is the refractive index? So we want to calculate what is N. So that is the relative refractive index that we have to calculate. So now this is at point P. Correct? At point Q, we can write the similar equations, and what do we get? This N21 will come out to be sine E divided by sine R2. If this is R1, this is I2, and R2 is R1 and I1. Correct? So now in the passage, do you remember what is given? Angle of incidence is equal to angle of emergence. So these two angles, they are equal. This is the refractive index of the prism. The refractive index is going to be equal because it is the same prism, correct? So this equation, let's suppose this is equation 1 and this equation 2. These two equations, they are going to be equal because the left hand side is equal. So the right hand side should be equal. So I can write sine I by sine R1 should be equal to sine E divided by sine R2. But we know that angle I is equal to angle E. Correct? It is given. Angle I is equal to angle E. And because of that, angle R1 is equal to angle R2. Yes? So now use this formula here. So let's use this in these two equations. So this R1 is equal to R1 and R2, they are equal. So let's call it as just angle R. So this will be 2 times R. And what is this I plus E? So I and E, they are equal. So I'll just call it as 2 times I. Correct? So from here, the I is equal to A plus delta. So this will be delta minimum, A plus delta minimum by 2. Correct? And what is R? From here, R is equal to A by 2. So I is equal to A plus delta minimum by 2, R is A by 2. And what is refractive index? Refractive index is sine I by sine R. What is sine I? Just now we have calculated, it is A plus delta minimum by 2 divided by sine of A by 2. Now just substitute the values. So what are the values given? Angle A is 60, delta minimum is 30. So A is 60. So this is sine of 60 plus 30 divided by 2. This is divided by sine of A is 60. So 60 divided by 2. So what is 60 plus 30? 60 plus 30 is 90. 90 divided by 2 is how much? 45. So this is sine 45 divided by, what is 60 divided by 2? It is 30. So divided by sine 30. So do you remember these values? What is sine 45 and sine 30? Do you know how to remember it? You know these two triangles? This is 45, 45. So it is 1, 1 and root 2 for 45 degrees. And there is another triangle which is 30, 60 triangle. If this is angle 30 degree, this is angle 60 degree and this is 90. So this is 1, 2 and root 3. So what is sine 45? For this angle 45, opposite divided by hypotenuse. So it is 1 by root 2. And what is sine 30? Sine 30 is opposite divided by hypotenuse, which is 1 by 2. Correct? So if you simplify this, multiply the numerator and denominator by 2. So you will get 2 divided by root 2, which is just root 2. So what is the refractive index of the prism? It is root 2. So n is equal to root 2. This is your solution. And if you can solve it, you can get 5 marks. So these are the competency based questions. So again I am telling you, don't get confused with this competency based. So some information will be given. Either it would be from your textbook, or for example here they have provided something else, something new information, and you have to make use that information to solve this question. So there can be just one question or can be more than one question, and once you solve it, you can easily get 4 mark, 5 mark question. You can easily solve them. Alright, so that's it for today. All the PDF for your question assignments and that whatever we have discussed today will be shared on this Telegram channel. Do follow us on the Telegram. Thank you so much. Bye bye. Take care everyone. Okay.